Hi guys, and welcome to exam school. As you can see, I have John next to me and we are doing grade 11. Grade 12s, you should be watching too, right?
Yeah, absolutely. Good. But welcome to the grade 11s. This is the first grade 11 exam school day. There are going to be lots of grade 11 exam schools. I know you're thinking, exams a long way away, but get ready now. We want to give you the help as well, and we want to try and help the grade 12s as they're going through. But there are going to be, as I said, lots of grade 11 coming up soon.
Exactly, and something that John and I really need mindsetters in today's show is lots of questions.
Absolutely. This is the time for you to ask your question. Remember, it's coming very soon that it will be a stupid question, because come the 5th, 6th, 7th, or 8th of December,
Then it's over.
it's over. Sorry,
Too
I'm
late,
not
sorry.
answering any grade 12 physics questions today because it's over. It's too late. Don't come and ask us for that.
Yeah, too late, guys.
Grade 11s, we're up for you. We're doing chemistry, though, today, so let's make sure that it's chemistry. So any chemistry questions you're battling, even if it's something as simple as, I don't know how to write the chemical formula for potassium permanganate.
Yeah, guys.
We'll
we're
explain.
taking them.
We're taking that.
Yeah.
That's what we want to do. We want to help you
And
as
you
much
know
as
what
we
we
can.
also love, John, is when, guys, sometimes you get that question in your book and you don't understand. If you've got a camera on your phone, please take a picture, send it through to us
Yeah.
on Facebook or Twitter, and we can always go through it.
Or also, helpdesk@LearnExtra.
Exactly.
Do-
.co.za. Hey?
.co.za. The thing that is difficult for us to get hold of is if you inbox us. And you know what? You don't get help from the other mindsetters. So don't use the inbox. Just post on the wall.
Exactly. So, John, you want to take a little
Yeah,
spot there?
we'll take the
and
spot.
I'll tell them all about the wall and Facebook and what they need to do. Guys, it's www.facebook.com/learnextra for Facebook. You can also chat to us on Twitter @learnextra. We are here to help you to take all of those questions. Also, remember that this community is for you. So if you do see a question on the page that you know, please help that mindsetter out. Post it there, because sometimes you can learn a lot by helping other people out.
And
so,
Indy, you know what? That's a really great challenge for the grade 12s. So if there are any grade 12s out there, you see a grade 11 question, become the teacher, because you will be so much more effective in the way that you answer the final exam question, which is on Monday. So you've got some time to wait for paper 2. But by helping the grade 11s, I think that would be great.
Brilliant. So, John, I think what you should do now is tell them a little bit about Curio and tell them, how do we get on this Curio? I want to know.
It's there. It's on your phone. Okay? So Curio is a new thing. Grade 11s, we haven't spoken to you about Curio. We're really excited. It's in the testing phase. So guys, don't get too frustrated. We're really looking at it as a way for us to get feedback from you. But we're developing stuff at the same time. So it's a platform that is working through Mixit. And we're posting some questions then. We'd like to get your responses. The idea is, what we'll do is we'll get the responses, see where the problem areas are so that we can address those in a future show, or we can address them on Facebook. We'll definitely be posting the answers to today's assignment, which is a grade 11 assignment. Only 5 questions, but they're multiple choice and they're going to be based on what we're doing today. And what we're doing today is we're going through, as I said, some basic chemistry. So chemical reactions and energy. We're going to be looking at the energy profile graphs. We're looking at types of reactions. We're looking at redox or redox. I prefer to say redox. And then oxidation numbers. We'll also look at chemical calculations. So that thing that everyone runs away from, Indy, you know what? In grade 11 and even grade 10 now, they run away from a thing called a mole. And it's not a furry thing. It's a calculation. So let's not be scared of the mole. Okay? Today we're conquering the fear of the mole. I know there's some grade 12s that are scared of the mole too. But we're going to sort it out today.
Fantastic.
Okay. So let me talk to you about, that's what we're dealing with. And we've put some questions together on Curio, platform on Mixit. This is how you get hold of it. So let me take you through the quick instructions. Not going to spend a lot of time. We'll post them on the page as well. So the first thing you're going to do, it's an exam school test yourself brought to you by Mindset Learn Extra, and it's powered by Curio. And here we go. Here are the instructions. I'm making a mess.
That's okay, John. I have the instructions here too.
So here we go. Here are the instructions. So Indy will post them. You obviously need to log on to Mixit. So if you haven't got Mixit, download it, get it onto your phone, and log on to Mixit. Once you logged on to Mixit, you go to Add Contacts. Once you've added contacts, under Add Contacts, you go to a drop-down that says Add Contact Manually. And in that, you enter the following ID, which is very important. It's qa.ed.ge. So I'm going to say it again, qa.ed.ge. Once you've filled in that ID in the text box, what you'll be submit, and you'll be sent a confirmation. You say send invitation and finish. Okay, so you finish that. You send invitation and finish. That means you're in the downloading process. Downloading is done. So you've got it downloaded, and it's now an app on your phone. You now have to register. And the registration process, part 2, says what you've got to do is you go to your apps menu, which is the third button on the top on the Mixit thing. It's a little wheel. You'll know where it is. Go to the apps menu, and you're going to look under general apps. Guess what you're looking for? Yeah, that's it. It's qa.ed.ge. That's what you need to look for. Once you've clicked on that, you must enter your name. So I've entered my name as John, and then I've entered my phone number, which I'm not going to put on the board. Because I know that I'm going to get some calls if I do.
John, please help me with that
help
question.
Me, yeah, I've had one of those already. Okay, once you've done that, what will happen? Nobody else is going to see your phone number. It's just to let the administrators of the platform know that you've registered, that you're a genuine register on Mixit. They're going to send you a confirmation SMS. This you do not have to pay for. Mindset is paying for those SMSs. So you will be sent a confirmation SMS. In the confirmation SMS, there's a special number. And that's very important for your first time completing your registration. So what you have to do, after you've got your SMS, you then take this number that is on the SMS and you put it in on the text box on the login. So you fill in. So it could be a number like 1234 on your SMS that's been sent to you, and then you fill that in, that number. It's a straightforward number that gets filled in. You fill it in, and it says, yeah, welcome. You're part of the team now, and you'll see the Learn Extra sign. And I think Indy might even be able to post for us a couple of pictures, what it looks like on Facebook, so that you can see it. You know that you're on the right track. Now, that's the process of actually logging in. Once you've done all of that, you're wanting to go and do an assignment. You want to go and beat the challenge. See if you can answer my questions. And this is how you're going to do it. On the home page, you're going to click on Enter Curio. So this is when you want to go and test yourself. You enter Curio. Now today's Curio, the one that I want you grade 11s and any grade 12s watching to enter, is PSCI 25. PSCI 25. And it's going to come up with grade 11 chemistry. That's what you'll be assigned, grade 11 chemistry. And then, guys, you start the assignment. There are only 5 questions. Don't drop out. Come on, you can do it. You can take as long as you like. You just have to go back and refresh if you do log off. But please go through all 5 questions. And after today, I'm sure you'll be able to answer all of those. And you select, there are multiple choice questions. You select the right answer. You, on question number 1, let's say it's A, B, C, D. You have to fill in the right answer. I can't remember what the right answer is. Let's say it was D. So you think that D is the right answer. You push D, Mixit will refresh, and you'll see the question with a little star next to D. That's saying that's the number you've selected. Okay? Once you've done that, you can then select next question. Okay. Now, after answering all the questions, please wait and find the submit button. You either got to look for that after the last question or go to next, submit your answers. It will push it up onto the platform. We'll get your results. We'll know exactly what's happening. We're working out a way to give you feedback. It might not happen today, but within the next couple of weeks or so, next week or so, we'll be able to give you your answer, for you to be able to get feedback as you're doing these quizzes to know that you're on the right track. In the meantime, we're going to use Facebook to give you the answers as well, and we're going to use the show as well. Okay, so get onto Curio, see if you can sort it out. Let's see if we can get, how many do you think we want to get in today's show? Do you think?
How many tests? I'm curious.
Yeah, how many guys?
I reckon 40, 50,
I know,
80.
No, indeed.
Higher.
You know what?
Higher.
The grade 12s, here's a challenge, grade 11s. The first day, the grade 12s, 1,000 of them registered.
Okay. Well then grade 11s, I want 2,000. 2,000 grade 11s.
Do you think the grade 11s can get 2,000?
Yeah, I'm sure.
Okay,
You
let's
guys
see if we
can
can do
it.
it. Okay.
Yeah.
Guys, but what we really want is not just 2,000 of you registering on Mixit. We want to see how many of you can get all 5 answered. And we'll try and find out how you're doing before the end of the show as well. Okay, to give you some feedback, we'll give you some hints if you're not doing that well. Okay, but we really want to go through this, help you to prepare for your exams. Now, guys, we don't know exactly when you grade 11s are writing. That's why we can't schedule a show directly before your exam. I know it's coming up soon. Different schools will write at different times, but we're going to be here to support you. Remember, the help desk is also available. Right, let's go. We're going to start question number 1. We're going to start with talking about reactions and energy. Some basic chemistry, some revision of some energy concepts. Energy and reactions. Okay, so this is a graph that is really important. It's called an energy profile, and they tell you that you've got a reaction that's taking place. It's a hypothetical reaction. That means it's not one with real elements. It's just given to us with some x's and y's. But let's have a look. And we see x2 plus yz2 gives you xz2 plus y. So have a look at what the energy profile looks like. We've got potential energy on the vertical axis. We've told that there's things called the reactants, with 40 kilojoules, and we're told that this is the progress of the reaction, or the reaction coordinate. Now, I just want to stop there for a minute, because whenever you're given a question in an exam or something like that, it's really important that you analyze and that you check the data that you've been given. So let's have a look at this particular graph and look at the equation. And as I said, I'm going to go right back to really elementary stuff that I know lots of people battle with. When you're given an equation like that, remember that the things that you start with, those are called the reactants. Okay? The things that you end with, these are called the products. So, our reactants are X2 and Y2, and the product is xz2 plus y2, but plus y. Now, when you get a chemical equation like that, one of the first things you need to do is to check that it is balanced. Understand that the number of atoms that are represented by the equation on the left-hand side of the reactants must be the same as the number of atoms represented in products. You can't suddenly lose an atom along the way. So have a look. We've got 2x2, and on this side, look over here. There's a problem, because what's happened is that this isn't 2x2. It's only 1x. That's an imbalance. Can't be. We must make sure that whenever we write an equation, that it must be balanced. So be careful. Check the balancing process. I know that this is grade 10 work, but you can get asked it in grade 10, you can get asked it in grade 11, you can be asked it in grade 12 as well. So how are we going to do this? Let's see and make sure that we can. I hope that we can, because I think it was a typo that we actually got that, but we're going to try and check it. So x2, we've got 2 of those. We need to have 2 in front. Now, notice I put a big 2. I can't suddenly put a 2 over there, or put another x somewhere else. Can't do it. I must put the 2 in front of the x. Got it. We now have 2 x's, and we've got 2 x's on this side. Now, what about the z's? I hope you can see that we've now got 4 z's on this side. There are 4 of the z's. Let me just write that in a different color so you can see it more clearly. We wanted the 2 nice and big, but we've got 4 z's because we've got 2 times 2, which is 4. So 4 z's over there. But on this side, I've only got 2 z's, so I'm going to have to put a 2 in front of that. Now, that means I've got 4 z's over there. So 4 z's, 4 z's. It's balanced. But what about the y's? 2y, only 1y over here. How am I going to balance it? I'm going to put a 2 in front. Okay, so guys, that's the process of balancing. If you're struggling with writing formula or balancing, you've got to get this sorted out. It can cost you huge marks in the final exam. So try and make sure you've got it sorted in grade 11. It's too late if you're in grade 12, I think. But even if you've struggled with balancing, try and get it sorted out. Make sure you check. Indy, I think it's time for a break.
Oh, no, not already.
Already.
Surely. Okay, well, that gives me time to go and get some water, get yourself a cup of tea, and ask questions and stretch. Guys,
get onto Curio.
Get onto Curio, and please, 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 now we need you to post questions. We really want to make this show interactive, because at the end of the day, it's not about us, it's about you guys, about learning more and learning extra. So give Curio a little bit of a bash while you're waiting for us to come back, and we'll see you now. Hi Mindsetters, you are back. I hope that you gave Curio a bash. Let us know on our page, facebook.com/learnextra, what you think about it and if you find it useful. And I think it's pretty fun. I've been playing around on it during the break, and I think it's kind of fun. And it's really nice to test your knowledge, guys. And I just wanted to say a big up to Liberty. Thank you guys for making this show possible. Without you, we are nothing. So thank you very, very, very much. The Mindsetters appreciate it, and we appreciate it. So now I see Ashworth is on the page. He says that he hasn't seen me in long. Ashworth, I haven't seen you in forever. So here's a big hello, and I hope that you've got a good question for me, because Mindsetter, I know that you've got those good questions. And that's what we want to do. This show is all about us, not us, it's about you and us helping you guys. I see here we actually do have a question from Akadi, but what we're going to do, and Seymour, yes, guys, you rock. I'm going to let John go on with his lesson, and then as soon as John's finished with this, we're going to start going through those questions, so you guys better keep them coming. John, take it away.
Right, guys, let's just finish off this question on the energy profile. We went through a little sidetrack on balancing equations. Hope you've got that sorted out. I think that I'm going to give you a balancing thing to do just now. It's a little bit of a challenge question. I'll get Indy to post it, and we'll put it on the board as well. Let's see if you're up to it to meet the challenge of being a balancer. Okay, but now let's get into the story about what the question's really asking us. So we're looking at the energy profile. I'm just going to erase that 4Z there. And what we need to recognize is we're starting with the reactants. The reactants, and we can take those from the equation now. Remember, the reactants are simply X2 and YZ2. When they ask you, what are the reactants? Don't confuse it and put the balancing numbers in. That's just for a balancing equation, so you can ignore those. Where are the products going to be? Well, the products are down here. That's the energy of the products. And so we're going to say the products that we're dealing with are X, Z2 plus Y. And there we go. So the first question says to us, what is the activation energy of this reaction? So I want to remind you that when we're dealing with reactions, what happens is you need some excitement to get the molecules combining. Now, I know that there are all sorts of stories about how you can relate chemistry reactions to what happens between guys and girls, and particularly you guys out there when you go to parties and you have dates and all that sort of thing.
It's all about chemistry.
Yeah, it's all about chemistry. Yeah. So if you've got a guy or a group of guys and they're just sitting around being bored and they're not very excited, they're in their ground state, they're relaxing off, and a pretty girl walks past, the energy changes. They suddenly look a bit smarter, they pull their shirts around, and they want to puff out their chests because they're into an excited state. Now, what happens with molecules or atoms that are combining is they get into an excited state and they're bumping each other around. So what it is we recognize that chemical reactions take place because of collisions. And we're going to learn, grade 11s, you're going to learn a bit more about that next year, but they get into an excited state. So they have a sort of low energy to start with, but as they get closer to each other, there's some increase in potential energy. And that's what we're seeing here. This energy hill, so that's like a ground state. They gain some energy and they get into an excited state. This excited state is called an activation complex. Activation complex. And so in this case, what we'd find is that we'll have X2, and it kind of sits next to, so that was one of the things. Let's just draw it out so that you can see it a little bit clearer. I want to try and illustrate this activation complex. We're going to have X2, something like that. And over here, we're going to have Y and Z and another Z. And these guys are going to start to bunch up together. So they're going to start posturing so that we get bonds forming there, and perhaps a bond forming there, and another one on the other side, and that's called the activation complex. Now, those are temporary sort of attractions between there and there. They're very temporary. There will be another one on the other side that can actually get the X's each having two of them. So this state is not stable. Could fall apart and go back to this initial stage. So the molecules could bump together and then they could go back. But they could combine and they could be successful in forming a new product. So if we had another one of these Z2 things, and I just illustrated for you, just pull this up a little bit so I've got some space there. We've got another Z, Y, Z over here. Now look what will happen. What we're recognizing is that this guy comes in here, and now can you see what will happen? Is that the bond that is in blue, this one, I'm going to erase it, the small one. Hope I've picked a small eraser. Yes, I have. This bond is going to break apart. That bond is going to break apart. That one's going to break apart. That one's going to break apart. And what have I got? I've got this thing, which is a new product. I've got that thing, which is a product. And notice I've got two of the Y's that are products. So that's my product there. And it's exactly that. What then happens if that forms? They release energy. So being high in energy, they release energy. This is energy given off, energy released. But to get to this activation complex, you need energy. And the energy that you need is called activation energy, EA. Okay, so they're asking for us to use the graph to find out what is the activation energy. So given a graph, you have to work out what's the activation energy. Well, the potential energy of the activation complex is 80 kilojoules. So we're going to say activation energy is equal to 80 kilojoules minus the energy that we started with, which was 40 kilojoules. And so the end result is going to be 40 kilojoules. Got that? Notice it's a positive value. You have to increase the energy. You usually give the energy to the reactants by adding a little bit of heat or adding light. It just depends on what the reactants are. Let's move on to the next one. It said, now, here comes the tricky one. What is the enthalpy? Oh, that's a tongue twister of note. enthalpy. Makes you kind of, it's a funny word, isn't it? Enthalpy.
Ridiculous word.
It's a ridiculous
Ridiculous.
word. Yeah. But all it means, it's another word for a symbol that we say delta H.
How do you say it again, John?
Enthalpy.
Enthalpy.
Yeah, enthalpy. It's a very important thermodynamic principle, and we don't cover it in detail at school, but just simply to say delta H, or sometimes called heat of reaction. So it's a measure of the energy differences between the product and the reactant. So let's get it right. Let's make sure that we've got it right as well, because what we're going to compare is the amount of energy released, okay? So this is energy given off to the energy put in. And the enthalpy is always going to be, in this particular, when we define enthalpy, we're going to compare them. We're going to say it's the activation energy, when you're looking at the graph, minus the energy released. Another way of saying it is you're going to take the energy of the product, and you're going to subtract the energy of the product minus the energy of the reactants. So if we do that, let's have a look. What have we got here? Energy of the products over here, minus 60. What was the energy of the reactants? Have a look at it very carefully. It's 40. So if we take minus 60, minus 40, hope you can see that in this case, the enthalpy is going to be negative 100 kilojoules. And I'm running out of space on the side there, but I hope you can see that. So we've got that. Notice that in this case, the enthalpy is a number that is less than 0. It is negative. Negative value over here. A negative value, very important. And what we can see here, that means that more energy was given out than was taken in. More energy was released between there and there than was included at the beginning. So be very clear about that. It's going to help us with the next question to analyze. This could even be in a matric exam, but could also be in a grade 11 exam. In fact, I'm sure it will be. You probably will get a question like this in your chemistry paper. Is this an endothermic or exothermic reaction? So let's think about it. Thermic refers to heat. So we've got thermic, which is heat. Exo means in or out. Which one? Exo. Come on. Exo. Indiana. Exo.
Thermic.
Exo.
Thermic.
Exit.
Oh, yeah, okay. Exo, exit.
Going?
Out. Out.
Oh, out. Okay. So we're definitely going to go out if we have exo. That means energy is out, being given out. It means it is released. Endo means in. Okay? It's coming inside. So exo and endo, don't get them confused. What's also important here is that when it's an exothermic reaction, we've got more energy given out, and that means that delta H is going to be less than 0. In other words, it's going to be a value that is going to have a minus sign in front of it. It's going to be negative. Whereas the endothermic reaction is going to be one where delta H is going to be greater than 0. Now, I know this might sound trivial, but lots of kids, lots of grade 11 and even grade 12 learners don't know how to read greater than and less than. So I want to remind you that it's like the crocodile. The crocodile is snapping to the bigger side, Okay, so think about that as having a crocodile teeth. And if you see it like that, the crocodile wants to get to the one that's bigger. So this is saying it's bigger than 0. This is the bigger side. Okay, bigger. This is smaller. So we say delta H is greater than 0. Means it's positive. On this side, look where the crocodile teeth are going. See the sign? There are the teeth. And it's snapping at the 0. It doesn't want the negative. It wants 0. Because over here, this is small. And this is big. 0 is big for the crocodile over there. Hope you got that. So here, let's go back to the graph. What are we going to answer? From this graph, we can see that there is more energy given out, that delta H is negative. So this is the delta H value on the graph. If we asked to show it, the difference between a product and a reactant. Just want to put that in again. It's because it wasn't coming out too nicely. Delta H is negative. And what you need to recognize there is that because it's negative, it's below that. So here's a question for you, just very quickly, and we haven't got a lot of time. When it's got a big step down, then we know it's exothermic. So what would it look like if we drew an energy profile of something that is endothermic? Before the break, let's fill it in. So if we had an energy profile and we want to have an endothermic reaction, so I'm going to have my reactants over there, or no, let me put the reactants lower down. Reactants with a lower energy, we're going to say this is EP, potential energy, and this is the reaction coordinate or the process of the reaction coordinate. Just simply means how the reaction is proceeding. And we're going to say the products are over here. They're the reactants. Let's fill in the plot. We're going to say, go up there, and there we go. That's an endothermic reaction. That's the energy profile for endothermic. Notice that delta H is still the same. It's between there and there. That's delta H. This is the activation energy. Okay. Right. Well, I hope you've got that. Guys, it's important to get this grade 11 knowledge into your heads because you're going to use it next year when you come to grade 12. Okay. Indy, shall we
Let us take, shall we take a little break?
take a cup of tea?
Yes. Okay,
Or a
guys.
stretch?
Exactly.
Very good. Get some oxygen in. Move
Very
around.
important.
Yeah.
Very important. And also, guys, I see a whole bunch of mindsetters are posting questions, and also the matrics are saying that their physics paper went really, really well. So we just want to say big congratulations to you guys, and we are so glad that it has gone so well. I do have a little screen grab here of somebody that I want to read to John. Obviously now. So now this is Ntando, and Ntando's always on the page, and Ntando says, this is the first time I've written a paper in physics and finished an hour early. So that is awesome. So it's the first time she's written, and she's never felt confused. This is my last physics high school paper ever. So grade 11s, this could be you next year. Grade 12s, I hope that you are watching to make sure that your paper 2 goes swimmingly. Hope you have a fantastic show, and we will see you guys now after the break. Hi guys, and welcome back to Mindset Learn. This is Exam School Grade 11s. I hope that you are tuning in. Grade 12s, you guys as well. I hope that you are really enjoying Curio. Let us know what you think. Take those tests, check it out. I think it's really, really fun. And when you make learning fun, I think that's awesome. So join us on facebook.com/learnextra. Also chat to me on Twitter @learnextra, and keep those questions coming. Guys, we really want the show to be interactive. We want the show to be about you. So what we're going to do is we're going to take a question from Takalani. And Takalani is always on the page, and I always get so happy when I see his face. And Takalani wants to know, John, what is the effect of adding a catalyst in a reaction?
Okay, that's a great question, Indy, and it really fits in with what we've been doing. I know that I saw another post that Takalani had, and we'll just come to that and clarify it as well. But let's do the catalyst question first. A catalyst is a chemical substance. Now, it's very important that you understand this. So if we take our particular reaction that we were dealing with, and I now need to just go back up to it, and we had here x2 plus 2yz2 gives you 2xz2 plus 2y. And we've explained how that whole process works. But now, if we had a catalyst, it could be something like AB, okay? Another substance. And what happens, guys, is that when we put this into the mixture, it helps the other substances to form partners. I like to think of a catalyst as a bit of a matchmaker. So you know what the story was when I was saying the guy sitting on the one side, pretty girl walks past, they get excited, they bump into each other and they go off and they have a date and so on. Yeah, that's a chemical reaction. But now what we have is a catalyst that kind of knows a pretty girl, knows a guy that's quite a nice guy, and that he introduces them, and then he disappears from the scene without getting involved himself or herself. So a catalyst is like the thing that gets the two parties together and they have a fabulous date and they move off into the sunset. Guys, that's what a catalyst does. Brings the reactants and the two reactants together to allow the products to form. The catalyst is not changed or not used up. If we had 5 grams of catalyst at the beginning, we'll have 5 grams at the end. We'll have the same amount of catalyst in the container before and after. Very important for you to understand that. Now, in terms of energy profile, let me show you what the catalyst does. And I'll go to this graph because it was just drawn a little bit bigger. And it's often in an endothermic reaction that we have catalysts. I'm going to draw in the orange line to show you what the energy profile of this reaction would be if we had a catalyst. So if we had a catalyst, what it does is it lowers the activation energy. So it becomes smaller. Can you see that? That the energy required now, the activation energy is less because there's an alternative pathway. This is for a catalyst. There's an alternative pathway for the products and the reactants to get together. Remember what we said over here was to get this reaction to go, we needed 2 molecules of ZYZ to bounce into a molecule of XX. But if we had a catalyst, maybe the catalyst could hold XX in place and then allow the other things to come along and to do the chemical reaction. So, in brief, that's the question, that's the answer. A catalyst is everywhere, all around us, in our bodies. There are things called enzymes. Those of you that are doing life sciences, enzymes are examples of biological catalysts. So they work like a lock and key. These molecules sit together to allow a chemical reaction to take place. Takalani, you also asked about the activation complex and a transition state. Yes, they're the same thing. Okay, so get the terminology. They're both usable. They are a temporary excited state, transition state between product and reactant, activation complex, and they have the most potential energy. That's why they're up at the top of the, after they've received all the activation energy. But I think it's time to move on. Let's move on to talk about something else. And I know that a lot of people battle with this idea of reduction, and oxidation. And for grade 11s, we call that process a redox reaction. But before we get into redox, we need to talk about oxidation numbers. Now, oxidation numbers are related to this, and it's really important for you to understand this. An oxidation number tells us whether a substance is electron rich or electron poor. And we've got to just apply some basic rules to sort out whether something is what its oxidation number is. This is very useful, even though in grade 12 you're more than likely to be given a sheet of half reactions, a reduction and oxidation half reactions. It's still important you could get asked about what's happening, and it might not be on the sheet. You have to use oxidation numbers sometimes. So understand the principle of oxidation numbers. Has a substance gained electrons or has it lost electrons? And that's what oxidation numbers are all about. Okay, so let's go and look at these ones. Hopefully they're not too difficult. What is the oxidation number of sulfur in the following compounds? We've got A, S8, sulfur, B, NaS, C, H2SO4, D, SO2, and E, SO3. Well, before we go and answer all of those, I just want to have a quick reminder of how to assign oxidation numbers. What are the rules for assigning oxidation numbers? Because maybe some people have forgotten. So let's just go over those rules. So the first rule is that any element will have an oxidation number of 0. So if I have an example of Z, it has an oxidation number of 0, and we write the oxidation number of one atom above it. We'll come to the next one. Second thing, compound. For a compound, we're going to say that the total oxidation number is equal to 0. Now, what do I mean by that? If I take an example of NaCl, nice compound, product table salt that you use, we say if we take the oxidation numbers of these two substances and we add them together, we will get an answer of 0. Okay? We'll come back to this to show you what the unit oxidation numbers of each of these. Oxidation number is like valency. And so what our next statement is going to be is that if we've got a charged substance, so ions will have the same as their charge. The oxidation number, ox number, is equal to the charge. So we know that sodium is an ion, forms an ion, and it has a charge of +1. And chlorine, or chloride, sodium chloride, a charge of -1. So you can see +1, -1, they cancel each other out, and the total oxidation number is 0. So what we recognize as well with ions is that the total oxidation number, total ox number, is equal to the charge. So let's go through an example. So if we've got a radical or a polyatomic ion like NO3, we know that's the nitrate ion. It has a charge of -1. The total oxidation number here won't be 0, but will be -1. Okay, we'll come back to this one as well, just to sort it all out. And then really the last two that we can get to, or the last, and they're really quite important, number 4 and 5 of the rules, I think you can do most things with after you've done these, is that hydrogen, when it's combined, whenever it's combined in a compound, then it's going to have an oxidation number of +1. And similarly, if we take a look at oxygen, in most cases, when it's combined, it's going to have an oxidation number of -2. So if I were to apply this rule to my nitrate, let's see what that would give me. Just to show you how we'd assign it, we say oxygen is -2. -2, but there are 3 oxygens here. So 3 times -2 is -6. I want to get the total to be -1. So what's the oxidation number of nitrogen? So what plus -6 will give me -1? It must be +5. Now notice here, oh, that's terrible 5. I'm going to try and draw it neater. +5 there. There's only 1 nitrogen. So the number at the top is going to be +5 as well. Got it? Hope you have. recognize the way to assign oxidation numbers. Now let's apply those rules and see if we can answer the question. And we are going to make sure that we get these correct without too much difficulty. So have a look at this. Sulfur over here is an element. So what do we know about the oxidation state of sulfur? Well, the total oxidation state must be 0, and 0 times 8 is going to give you 0. So there's no doubt, as an element, will always be 0. Just by the way, don't get confused with this. Sulfur doesn't sit on its own. It bonds to other atoms of sulfur, and then that molecule is held together by intermolecular forces. Very important that you understand that. Right, let's go to the next one. Sodium sulfide. Sodium sulfide. Think about it. Sodium, we already saw, group 1, it's an ion, so it has +1. So, and I've made a boo-boo. That should be Na2S. Sodium is +1. There are 2 sodiums for every S. So where have we got? +1 is the unit oxidation number of sodium. So let me write that down properly. There we go. Sodium, we know, is +1 because sodium ions, it's a group 1 metal. There are 2 sodiums, so that's going to be a total of +2. +1 times 2 +2. What do we know the total is going to be? We know the total is going to be 0. So +2, what must I do to +2 to give me 0? I must find the missing number. Remember, the answer here was to find what sulfur is. I must subtract 2. +2 minus 2 gives you 0. So what is sulfur on its own? There's only one sulfur. -2 divided by 1 gives you -2. So sulfur is -2 in this particular case. So first one, it was 0. Now it's -2. What's it going to be in H2SO4? Let's try. H2SO4. First thing I'm going to do is I'm going to assign the unit oxidation number of oxygen, -2. -2 times 4 is -8. What about hydrogen? Remember, use that rule, +1 times 2 +2. Now, what do we know about these ones? Can you see that all of these oxidation numbers must equal 0? So what's the missing factor? -8 plus 2 is -6. The number I'm looking for, and that's going to be the unit, the total oxidation of sulfur is +6. +2 plus 6 minus 8, 0. Got it. 1 sulfur, so there's only sulfur in the +6 state. So I would answer this and say, in H2SO4, sulfur has an oxidation number or an oxidation state. Sulfur is equal to +6. Got it. Right, what about SO2? I think you're getting the picture. -2 times 2 is -4. That means that must be +4. So sulfur here is +4. Notice that even though it was sulfur, it doesn't have the same oxidation number all the time. It depends on what it's combined with, whether it's electron rich or electron poor. Let's do the last one. -2 for oxygen, -6 because I'm multiplying it by 3. So this one must be +6. +6 minus 6 equals 0. Check, that's right. There's 1 sulfur there, so this sulfur must be +6. Sulfur in that state is +6, and that is its highest oxidation state. It has lost all the electrons that it can do, and that's very important to know. Okay, on the other side, we noticed that sulfur over here with sodium sulfide had an oxidation state of -2. It had gained as many electrons as it could. So that's assigning oxidation numbers. We'll show you how important this is. But you know what, Indy?
Let me guess, John, it's time for a break.
I think a drink of water or a stretch or two.
I know,
Make
I
sure
need
you
it.
get those curio questions going. See if you can answer them.
Yes, exactly. Guys, mindsetters, please make sure that you do post your questions on the page. There are a whole bunch on the page already, so I'm going to go through them with John now during the break. You know, sometimes it's nice for us to have a break too, because that's when we get to go and check through the page and have a look and see where you guys are struggling. Because whether this lesson is for you, this lesson is for you guys. So what we're going to do is we're going to take a quick break, have a look at those questions, and we'll see you now. Hi guys, welcome back. See, I told you there was going to be a short break. I can't believe it, but we're going into the last half section of our show. I think we've got about 25 minutes, 30 minutes, so let's get this going. Don't forget that we are repeating this show tonight, guys, and if you're watching it in the evening, then it's obviously the repeat already at 10:30. So tell all of your friends that if they are missing the show right now, we are repeating it at 10:30, and then after that we've got chemistry for grade 11 all the way through to the morning. Also, something that I haven't said yet in this show, which is very important, and I will post onto the Facebook pages, guys, I know we've gotten to 22,000 now, but we did turn 21 the other day. And yes, we are still having our 21st birthday party, and that is happening on the 21st of November. And what we want is 21 mindsetters to be here in studio for 2 hours with us to have some fun. So we're going to have cake and sweets and music and some very exciting things happening here in studio. What you need to do is you need to email win@learnextra.co.za and tell us what you think a mindsetter is or what makes you a mindsetter. Also, don't forget to tell us where you are in the country, what your name is, and your contact number so we can let you know when you win that awesome prize to come and join us in studio. I will put up all the details on Facebook, and we cannot wait to meet the 21 of you lucky, lucky mindsetters. So now, I'm not going to take any more time away from John. Check out Curio if you haven't yet. Munaka has said that it is awesome, and there are a whole bunch of mindsetters that are saying that they are really, really enjoying it. And I'm going to see grade 11s. There better be more than 2,000 of you doing Curio because you've got to beat the grade 12s. But then again, grade 12 should be joining in too, so let's see how it goes. Now, let's not waste any more time. John, take it away.
Thanks, Indiana. It's been really great to be talking about chemistry. I love chemistry and I get carried away. Focusing in on things that I know that grade 11 struggle with, but please let us know. There's something that's bugging you. Ask the question. We'd really like to help you. If you're watching the repeat, that doesn't mean that you can't ask the question. Pop it onto Facebook or send a mail to helpdesk@learnextra.co.za and we'll get back to you. Make sure that you're informed exactly what you need to know. We'll either refer you to another show or that you can watch when that's showing, or we'll give you the answer directly by mail. Okay, so we've been doing some assigning of oxidation numbers. I've got another question on redox. And I'm just skip that one because I want to get onto this one. Because you know that in grade 11, you have to be able to identify different types of reactions. You want to go through those types of reactions. You have to be able to identify, is something a redox reaction? Is something an acid-base reaction? And then there are some organic reactions that you also need to know. Is it addition, substitution, or elimination? I want to try and cover those principles with you in this question. Okay, so let's go to this question, have a look at it, and let's see. Identify the type of reactions taking place below. So here we go. We're going to start with the first one. And we are given N2 plus 3H2 give you 2NH3. Grade 12s, you better know what this reaction is. It is the Haber process, the manufacturing of ammonia. But what type of reaction is it? Well, have a look. Let's assign, first of all, some oxidation numbers. So I'm going to say nitrogen is 0, hydrogen is 0 because it's an element. Now, apply the rule. Remember what we said. Hydrogen is +1, 3 of hydrogens is +3, and that means that nitrogen must be -3. There's only one nitrogen. -3 plus 3 means that nitrogen in this case is -3. -3. Okay, so what sort of reaction has taken place? Well, when there's a change in oxidation number, look what's happened. Nitrogen started at 0 and it became -3. Hydrogen started at 0 and it became +1. Let's deal with the first one, the hydrogen example. So hydrogen was 0, and there were two hydrogens, we know that, that each went from 0 through to +1. Okay? So what do you think is happening there? If it goes from 0, where it's neutral, and it's now +1. It's just H on its own, and we know that there were 3 of them. We can sort the balancing out just now. But from 0 to +1, I guess that means that must be a loss of electrons. Because if it was neutral and it's now positive, that means it's got 1 extra proton compared to electrons. It's becoming electron poor because it's +1. So it has gone from 0 to +1. It's lost electrons. You need to know that that process is called oxidation. Oxidation is a loss. And whenever we get one thing changing oxidation numbers, we can say this is a redox reaction. Because where did that electron go to? Or those electrons go to? Those electrons just didn't float off into the atmosphere. No, they were transferred. The number of electrons lost by hydrogen is the same number of electrons that will be gained by nitrogen. Look what's happened to nitrogen. Nitrogen, over here, the pink thing, went from 0 to -3. So that was a gain of 3. Now, I'm not going to go into the balancing story, but just to recognize that there were 2 of them there, so it was actually times 2. So that's a total of 6 electrons there. And if we recognize that this happened 3 times, and 3 times 2, there's going to be 6 electrons here as well. So this process of nitrogen gaining electrons is called reduction. Notice the oxidation number is getting less. It's becoming negative. That's why it's called reduction. Seriously though, reduction is the gain of electrons. So it goes more negative in its oxidation number because it's gaining electrons. Hope you've got that. So whenever there's a change in oxidation number, we know it's a redox reaction. Be very clear about that. Now, have a look at the next one. And these ones are quite similar. And I'm just going to put that out again. 0, hydrogen is +1, and hydrogen is 0. Immediately, you can see there's a change. For hydrogen, it's gone from +1 to 0. Now notice, previously, hydrogen went from 0 to +1 over here. It went from 0 to +1. So hydrogen can do that. It doesn't mean that it's always going to be oxidized or it's always going to undergo reduction. It can do either. That's what makes this section on redox chemistry so interesting and so useful. So in this case, hydrogen went from +1. It is gaining an electron. So we know that it is a redox reaction. What was the other thing? Redox reaction. What was the other thing that changed? Well, zinc changed. Over here, if we had to work it out, we would see that chlorine is -1. It's still -1 over there, but zinc is +2 over here, and it was 0 over there. So there has been a loss of electrons. Zinc lost electrons. In other words, zinc underwent oxidation. Right, last one for this particular thing, and let's have a look at it. We've got NH3 again, and HCl, and we've got NH4Cl. What do we know? Well, from previously, we know that that's +1 and that's -3. That's +1 and that's -1. Now, NH4 is a positive, so that first part is an ion, is positive, and the chloride we know is minus, so that will make that sorted out. So -1, and so now hydrogen is +1, and there are 4 of them. 4 times 1 is 4, and there's only one of that, so that means that nitrogen is -4. Okay? Sorry, there are 4 of them. and that needed to be +1. So it's not -4. My mistake. It must be -3 because we want this total to be +1. So it's -3. So have a very careful look here. Nitrogen was -3, hydrogen was +1, there's no change. No change in oxidation number. No change. Don't abbreviate, but you'll know what that means in ox number. So be very careful about that. If it's not an oxidation half reaction or a reduction half reaction, what sort of reaction could it be? Well, let's try an acid-base reaction. An acid-base reaction where a hydrogen ion is donated. Let's see if we can see what's happening here. If we have NH3, and I'm just going to sketch the graph or the little diagram, represent ammonia like that, and we have hydrogen chloride, and we're going to say hydrogen chloride is like that. Look what could happen. We know that there's an extra pair of electrons sitting over there. This hydrogen gets pulled over to that extra pair of electrons. And so what happens is that this bond breaks and the hydrogen doesn't stay there anymore, but it undergoes something. It gets added to form this process or this ion called NH4, ammonium ion. This bond here is known as a dative covalent bond. It's dative covalent bond because it's sharing electrons from the lone pair of the nitrogen, where the chloride now is sitting on its own. What do you know when you have a positive and a negative? They're going to be attracted to each other, and that's what sticks them together. So what has happened? Hydrogen has been donated. And what do we know when we see hydrogen donated and hydrogen accepted? We know that that's an acid-base reaction. Indy, how are we doing? Have we got any questions?
We are doing so well. Let me have a look and then see if there's anything we can answer straight away.
Well, while you're looking, just interrupt me. As soon as you've got something there, I want to do one other thing. I want to remind the learners about addition. Now, I know that when we talk about addition, what we generally mean is that if we have two things to start with and we're going to get one thing at the end, that's addition. In chemistry, what we need to recognize is that the opposite process, that's building them together, the opposite process is called, and I want to just change my pen to put that in a different color so you can see, that opposite process is called elimination, where we start with one thing and we end up with two. Very important that you understand that. And then the last type of reaction you're going to need to know is substitution. Now, we had an example of substitution earlier, and I'll just show that to you, where we started with our very first thing. Here we go. Look, the partners that went to the dance were Y and 2Z. What stayed at the dance? X and 2Z. Do you see? They switched dates. X2 came on his own, and Y went home together without a partner. Okay? Two Ys just drifted off, and they weren't attached anymore. But they swapped partners. That's why we call it substitution. The big thing in organic chemistry that you're going to need to know, and you could get asked this in grade 11, and I just want to remind you about it as well. When we talk about addition, the type of chemistry we're talking about is where we take something that's got a double bond, something like ethene, and we put something that wants electrons. Now, something that wants electrons is something like bromine. We add those two together. Look what happens. The carbon always has 4 bonds. But we're going to show what has happened is that this second bond, the double bond, the second one between the carbons, breaks. And what we get is we get a bromine that is going to attach itself to the one side and another bromine to the other side. And it's gone from having a double bond over here to having a single bond over there. This is an extremely important test. In fact, it's a practical that you'll probably do in grade 12, where you will take something like ethene and you'll bubble bromine through it, or bubble it through bromine, and the bromine loses its color. It discolors. It decolors. And if it changes color and becomes colorless, it's orange to start with, orange, and it goes clear and colorless. Then what's happened? All the bromine has been added. It's no longer floating free to give the color to the solution. Okay?
Okay,
I think I've covered all the reactions I need to. How about you? What are you doing?
Okay, what am I doing? This is a good, guys, you better get those questions coming in. I think we've got about a few minutes left and we got to answer all of your questions. So here, are you ready?
Yes.
Akadi wants to know, so with oxidation, must it always be equal to 0?
Okay, we need to understand something, and I'll just try and put this very clearly and repeat the question. Okay, let's make very clear. If we've got a compound, the compound must be a total of 0. Okay, compound always 0. Element, like potassium, always 0. But if it's another substance, it can have different oxidation numbers. So, for example, oxygen over here is -2, hydrogen's 1, and sodium is +1. Okay. I hope that explains it and answers the question.
Yes, okay. So, but now what I'm going to say is, guys, we're going to go to our very last break right now. When we get back, we're going to answer all of your questions. So when we get back, this is the time we're going over questions. Because
okay, good.
We don't have any other questions on the board. I'm going to have
lots, but anyway.
I'm lying.
Yeah, I know, you're telling Porky Pies.
I'm telling Porky Pies because I want them to send their questions because I want to know what you guys are struggling with.
Very good.
And what you need to know for exams. So send them to our page, facebook.com/learnextra. Also tweet me @learnextra. It's nice, it's fast, it's easy. We'll see you now after the break. Sure. I can't believe that we are entering the last 12 minutes of the show. I've had such fun, and I've had such fun chatting to you guys on the page, learning more and learning extra, and that's exactly what it's about, making learning fun. If you see a question on the page that you seem to know the answer, please, guys, help other mindsets out, because sometimes that's the best way to learn, is by helping others answer the questions. So now, to your questions. Nolwazi says to John, isn't ZnCl, Cl should have a charge of -2, not -1? She's confused a little bit.
Right, thanks for that question. Very important question. Let's see if we can unwrap it and make sure that you're no longer confused. The first thing I've written up over here, but the first thing I've written up ZnCl2 as a reminder to me what we're going to be dealing with. So, let's take a look. What we need to understand is that chlorine is in group 7 on the periodic table, or it's sometimes called 17. So if you're looking at the old or the new one, grade 10s will know it as group 17, grade 12s and grade 11s as group 7. And we usually put that group 7 as a Roman numeral just to differentiate between them. But the international way of doing it, that chemists are now doing it, is calling it group 17. That means that is part of the halogens. It's not a noble gas. Now, let's just be very clear about chlorine. And I want you to understand what chlorine does, what it wants to do. It's in group 7, group 17. Wants to become like a noble gas. If we had to draw a Lewis structure of chlorine, we'd have to say, let's draw in all the valence electrons. We'd have to have 7 electrons around here. Okay? And it's missing 1. It wants to get to 8. It hasn't got to 8 yet. It needs to gain 1. Now, when it combines with zinc, the formula that we're looking at is zinc chloride. And we write it as ZnCl2. That tells me that I need 2 chlorines for every 1 zinc. Now, I know that chlorine gains an electron. Group 17, it becomes the chloride ion. List of ions tells me that it's going to get an extra electron from zinc, and it's going to sit over there. So how many electrons has it gained? It's gained 1. It's got a charge of -1. And so if we look at that, and we now apply the rules for oxidation numbers, what we'd have to say is that every chloride, because it's in group 7, actually has a unit charge of -1. Let's see if it works out. -1 because it is equal to the charge on the chloride. Okay? So -1 is the unit. So if I go and put -1 over here, and I multiply -1 by 2, I will get -2. -2. So -2 plus what will give me 0? Plus 2 will give me 0. So that's the total. And if we look at plus 2 over there, there's only 1 zinc, so the oxidation number of zinc is plus 2. But that shouldn't surprise us, because we know that zinc ions are zinc 2+. So I hope you can see, Lwazi, that the charge is very similar to the oxidation number. And that's why, looking at the oxidation number and at the Lewis diagram, you can see that chloride has gained 1 electron. Therefore, it will have an extra electron charge of -1. There's no space for chlorine to gain another one. No, it doesn't want to. It's become stable like the noble gas. Okay.
Okay, so guys, let's have a look. What other questions
There was
do
one
we
on
have
type
here?
of reaction.
There
How do we
was.
tell the type of reaction?
Okay, let me find
What do we
that
look
one.
for? I don't know who it was, but in the break you told me that that was one that we needed to do. So I've put down there so we don't forget it.
Okay, I've got this one from Palesa. Maybe it's this one, because we've got
Yeah,
quite a few
go for
currently.
it.
How much are we required to know about acid-base reactions? May you please summarize what we could be examined on?
Okay, sure, let's do. Because it fits in over here. I just went through the different types of reactions. You need to know redox. And we've spent a bit of time on redox. We also needed to know acid-base. And we'll come back to that acid-base now. And then we did the 3. Addition, elimination, and substitution. And I'll put them like that. Now, those are the 3. What are you going to do if you're given a question about identifying the type of reaction? First thing you do is you assign oxidation numbers to see if there's a change in oxidation state. If there's no change in oxidation state, it's not a redox reaction. And guys, the easy way to do that is always look and see if you've given an element, and that element, like H2 or even sodium, potassium, K, Na, on its own, and now the next thing, it's combined in a compound. That's a giveaway. Has to be a redox reaction. Like the Haber process one. H2, N2, and now you've got ammonia, NH3. Has to be a redox reaction. So identify by oxidation number, or C, has there been an element that is now a compound? Element to compound. If that happens, you know it's a redox. Okay. Now, what about acid-base? If there is no change in oxidation number, then what you're going to have to look at is what's happened to hydrogen. So let's have an example of an acid-base reaction here, where we say H2SO4 plus water, I'll just do a simple one, goes to form HSO4 minus plus H3O plus. Now, if you look at this, what's happened to the number of hydrogens here compared to the number of hydrogens there? I hope you can see it's gone from +2 to +3. So there's been a change. In other words, this has gained H+. So this is acting as an acid, sorry, this is gained an H plus, so it is acting as a base because it has gained. Where did it get it has accepted the hydrogen ion, so this is acting as a base, whereas where it got its hydrogen from, notice here, there was 2 and 1. So now there is less here. So what has happened to this thing? This has donated. So this is the acid. Now, the question that we were asked, can't remember who it was. You told me now. Acid base. No, not Lwazi. Next one.
Oh, gosh.
Doesn't matter.
I'll find it now.
You'll find it now. Said, what could you be asked? Well, you could be asked to identify the acid-base reaction. The second thing you could be asked to define. An acid is a proton donor. Proton donor. In other words, it donates a hydrogen ion. And I've tried to illustrate that there by showing you that it's gone from +2, it's given it to that one, so now it's less over here and there's more over here. That's what you could get asked with acid-base reactions. Anything, you could be asked about the pH scale as well. Remember, an acid has a low pH, a base has a very high pH. You won't get asked calculations, but you could get asked a calculation on the titration. What happens when you add an acid and a base together? You get a color change of an indicator. That gives you your endpoint. But I think that's going a bit far, and we haven't got time to fill that in. But make sure you revise that.
Okay, so do we have time for one more question?
One more question,
okay,
yeah.
Hopefully this is a quick one. And this one's from Katli, another Kaklego, not our present Kaklego, but one from Twitter, which is quite exciting. And she wants to know, how do we identify spectator ions in a redox reaction? Okay,
excellent question. And I've got one just like it, that here. So we went back to this one. Just very quickly, these ones, we were given this reaction, Fe2 plus H2O plus SO2 gives you Fe2 plus SO4 plus H2 4H plus. Now, the spectator ions are the things that would be hanging around here that do not change their oxidation number. So, for example, I could have had chlorine there. I could have had 3 chloride ions there. So instead of writing it in this form, I would have written it as a formula. I would have said FeCl3. Now, the spectator ion could have been that one. It would have been there and there. It has not changed its oxidation number. So the short answer, the spectator ions do not change their oxidation number. -1 there, -1 still there. It's not involved in the process of transferring electrons. Okay, have I got time just to quickly do this question?
Yes, quick.
Okay, quickly.
Do it.
It says, in this reaction, I'm just going to erase it, what I'd written down there, just so that you can see, we've got the whole reaction, and it says identify, in this reaction, the oxidation half reaction. We're looking for oxidation. So guys, let's see where the change of oxidation number is. That one was +3, that one was +2. Oh, look what's happened. It has gone from +3 to +2. What is that? It is a gain of electrons. Why? Because it is becoming more negative. It's becoming closer to 0, so it's gained electrons. So that's not it. What about the SO2? Well, the SO2 went from +4, you can check that, to +6. There we go. That has been your loss of electrons. So now we have to go and look for the option in this multiple choice of SO2, and there we've got it. SO2 plus water gives us that +2 electrons. Check. It's written like this. It's a loss of electrons, the electrons on that side showing that it's gained as a product. I think we're just about out of time. Indy, over to you.
I refuse that this is the end. Okay, so guys,
well, we can watch at 10:30.
Okay, exactly. Guys, watch again at 10:30. The exam school revision is back on. The show is on again. Thank you so much, Matrix, for an awesome show.
Grade 11s.
Grade 11s, don't forget. Sorry. Okay, Hope you guys had an awesome show. Keep those questions coming in on our Facebook page. Thank you so much for joining in. Also on Twitter at Learn Extra. And we are here to help you guys out as much as possible.
Last thing, tomorrow, grade 12s.
Okay, guys, tomorrow, don't forget grade 12s. Thanks for John.
Straight after this, grade 12s as well.
Straight after this, grade 12s as well. Thanks, John. See you guys. Bye.